Okay, today's podcast is a remake of the congruent and midpoint. There are several things that we need to discuss, and most of those are terms. So let's get on with it. The words to know: equal, congruent, bisect, segment, bisector, midpoint, angle, and angle bisector. Now, it seems as though these first two are the same, or pardon the pun, that they are equal, but they are indeed not. Let's start in with the definitions to see how well it goes. First of all, if I have a segment AB, which is 16, and segment CD, which is 16, let me move this out of the way a little bit, I can say that those have the same length. So I can say have the same length. That versus the fact that they have the same measure. Now there is a difference between measure and length. The measure is physically the distance between points A and B. So I could even draw this if I were to have not put that segment there. I could have put point A here and point B here and asked the distance between them. So there would not have been an object there. There would have just been space in between them. That would be known as the measure. But if I am asking for the length of something, you can only measure the length of an object. So that would be this segment right here. So equality is the same in measure. That would be equal because that is a number. And then the same in length would be congruent because that is talking about shapes. Shapes, shapes, shapes. Let me get that out of there so we don't get confused. Now that is what equality. So if I'm talking about these segments here, I can say that this segment AB is congruent to the segment CD. I cannot say that the segment AB is equal to 16 because this right here is talking about shape, where this right here is talking about measure, and this right here is talking about measure. So a shape cannot be equal to a measure. So how would I write that? Well, I would write that the measurement of AB is equal to 16. Nor could I say something like the measure of AB is congruent to the measure from C to D. That's not right. So yes, no, yes, no, because this is congruency. So you've got to either choose equality or you have to choose shapes, but you can't choose both. So this would be segment AB is congruent to segment CD, the same thing as I have up there, or the measurement from A to B is equal to the measurement from C to D. This is good and this is good. So I think that gives you some sort of idea about equality versus congruent. Congruent is talking about shapes, which has length, and then equality is talking about measure, which has some sort of distance. Okay, now let's go to bisect. Whenever you're talking about bisecting, you're literally talking about cutting into two equal pieces. So if I take some sort of ninja sort of death, or whatever you want to call it, and I cut this segment right in half, I could have gone through there. I could have just made a little bitty thing like that. Or I could have started right here and I could have gone that way. It doesn't matter where I go as long as I'm cutting AB into two equal parts. So that would mean that this part is equal to that part. That is what bisect means, cut into two equal parts. A segment bisector are these things right here. Those are the segment bisectors. This and this and this and this. Those are the, pardon the expression, but the ninja swords of death that come through and force some sort of bisecting. So the segment bisector would be the actual object. So a bisector is the actual object. Now, also in the discussion, we need to talk about the midpoint, because the midpoint here is the point at which the bisector crosses through. So obviously, if I were to choose that this point is F, then that would be that AF is equal to 8 inches. Or I can say that AF is congruent to segment BF. because the segment bisector goes through this midpoint, and that is an actual location. Things that do not get bisected in geometry would be a point. I cannot take a point and take half of it. I cannot also take a line, since a line never stops. If I were to take my ninja sword of death and cut it in half, now I wound up with a ray, but I didn't really find the middle of this line. So you cannot say that a line has a midpoint. You can only say segments have midpoints. Angles can get bisected, but planes cannot, because plane is a compilation of a whole bunch of lines. So that's kind of the deal with segment bisector and bisect and midpoint. Now, let's talk about angles. Angles are a little different breed. Angles, if you'll notice how I am choosing it, the way to draw them, that's not going to be it. It would be this one here. So I take one ray and I make it like that, and I take another ray and I go in a different direction, and that right there is called an angle. Now I can call this angle 1. If I put a letter there, I can also call it angle A. If I put some other letters, that would be ray AB, and this would be ray AF. So therefore, I can call it by its angle, but this right here, this point, is called the vertex. So I have to be sure to call the angle by its vertex. So I can either call it angle 1, or angle A by its vertex, or I can call it angle FAB, or angle BAF. What I cannot call it, and I'll write it in red so that you understand, I cannot call it angle BFA. Not necessarily because it doesn't exist. Angle BFA exists, but that would actually be talking about some sort of angle where F is the vertex, and it would be over here, so not there. So that is how you call an angle. Now, if you run into the instance where you have something, oh, I don't know, like some sort of line, and then you have there, you would love, let's see, G, H, J, and K. You can no longer call this angle H. The reason why is that there would be a 1 angle H and a 2 angle H, or even the straight angle of being an angle 3. So you cannot call this angle H. If you were calling it over here, if you were calling this shaded angle, you could call that angle 1. You could also call it angle 2, or you could call it angle GHK, or angle KHG. Those are the angles that you could call this shaded one over here, and vice versa. Now, if I need to draw some sort of angle bisector, that bisector is going to cut this angle exactly in half. So, bam, so that goes to there. Now let me show you a new page with angle bisector. Angle bisector, doesn't matter what it looks like, but you take this ninja sword of death, whatever it looks like, and it bisects that angle. So therefore it goes straight up through the middle, like so. To mark congruency on a bisector, you can say that this angle is congruent to this angle, and that is how you do an angle bisector. Let's see, so finally, I guess an angle is 2 rays. So if you'll notice, this angle here was created by this ray starting here, and this line that cut it in half. But whenever I'm calling this angle, whenever I'm talking about the angle, it is the connection of 2 rays that share a common endpoint. So the definition of an angle is 2 rays with a common endpoint. And that is the definition of an angle. If I wanted to show bisection, so what I can do is, let's say that I have this segment here, and I wanted to show that it got bisected. So all I have to do is, let's see, I don't know, segment JK, and I need to show that it got bisected, that JK is bisected by line LM. Well, first of all, segment JK is a segment by line LM is a line. So I need to draw some sort of line that goes through the midpoint. How do I know that this is the midpoint? Well, I need to make some congruent marks. How do you make the congruent? How do you show that, I don't know, JN is congruent to NK? Well, you put a tick mark. So JN currently is not congruent to NK, so therefore I put a tick mark over here. Now that means it's congruent, which would make N the midpoint. With that being said, LM has to go through that midpoint because it has to bisect. So there is a line, being sure to call that a line. So here is line LM, and that is how I can show that the segment got bisected. If I wanted to show that the angle got bisected, I could draw some sort of ray right here and show that this is congruent to that, and that is how you show bisection, and that is the end of this